Welcome to the webinar. We have quite a big crowd here, which is great. We have people from all over the place attending. So we'll be starting in just a few minutes. So stay tuned, hang in there, and we'll get going right at the top of the hour at 11 o'clock. That's Mountain Time. Okay, so talk to you soon. Okay, welcome everybody. Welcome to this webinar on high mix, low volume material delivery systems. And this should take an hour. I'm not exactly sure how long it's going to be. Haven't done this before. This is a first, but I think it'll fit within an hour, so stay with us for that amount of time. And welcome everyone. This is the largest, I think, webinar we've done. We have people from Europe, from Middle East, from India, all over the place. So welcome everyone to this event, this great event. So I'm going to be switching over to our presentation, but I just wanted to introduce myself so you know who's talking to you. And you do have room on your control panel here to add comments. So periodically I'll ask you for your feedback, and you can just type in the chat box. I think that's the best way to do it. But make a liberal use of the chat box on the left side, and we'll be monitoring it. For starters, let me just verify with you quickly that you can hear me, that that you got audio and it's working. So could you just type in yes if you can see me and hear me? Okay, just a quick yes in your chat box, and we'll take a look at that. I know Tim, you said sound. We've got sound on this side. Ian, at our control booth, you've got sound? Hey, Ian, you got sound?
Yeah.
Okay, so we got sound here. Okay, and most of you say yes. Perfect.
If they don't have sound, ask them to just hit the reconnect button.
Yeah, if you don't have sound, hit the reconnect button is the recommendation there. Or you have a local issue, because it looks like everyone else here that's responding is saying yes. Good, so we're set to go. So let's not dilly-dally. I'm going to turn off the camera. I'm going to turn on the screen share, and let's get going. All right. So designing high mix, low volume material delivery systems. Now in the past, we've asked you all for your feedback on subjects you'd like to hear about. And this is one that has come up a lot. So, and it's not surprising because high mix, low volume is pretty common these days, especially since non-repetitive manufacturing, or take that back, repetitive manufacturing has tended to go, at least from the United States, overseas. And so what we have left with is high customization, high mix, a lot of models. Also, the other thing that's happened is over time, in virtually any company, you keep adding new products, right? Developing new products, new offerings to your customers, but you don't get rid of the old ones. So over time, things tend to grow and get more complex. And I'll share with you a really extreme example of that in a minute. So with that, let's just get going here. And we'll go to next. So here's the webinar agenda. Here's what we'll be talking about. 5 basic sections. First one is the scope. So we'll define what we mean by high mix, low volume, make sure we're all on the same page with that. I've seen some definitions online in preparing for this webinar that I didn't really agree with in terms of the definition. So I'll have my own definition of what we're talking about here. And also, we're talking, what do we mean by material delivery? So that's important to understand because we're not talking about every single aspect of material management or supply chain management. We're talking about a specific subcategory of that domain. And then a little bit of discussion on what industries are typically included in this scope. And probably yours is included. I may not mention yours, but I'll mention the ones that came to mind, the most typical types of industries that are high mix and low volume. And then the meat of the presentation, we'll get into 5 options for material delivery systems in a high mix, low volume environment. Now, there may be more than 5, I'm sure there are. These are the 5 most common ones that we've run into and used. And we'll also talk, of course, about when each of these 5 would be most appropriate. Then we have parameters and tools. So I have a very simple tool, which I'm calling the decision matrix tool, that we'll be sending to you via email. It's an Excel tool to help you decide which of these 5 options for material delivery might be most appropriate for your environment. But the input to that tool is parameters. So characteristics of your company that you'll need to understand and then kind of assess and give yourself a score. And then based on those scores, we have a recommended strategy. And then at the end of the webinar, we have some discussions on what the next steps are, including a great offer, which I think you'll want to stick around for. So that's it. We're going to fit all of that into an hour. So let's just start going here with our definition. So what is high mix, low volume? This is my definition. However, below on the screen, I don't know if you can actually read this or not. It's a little bit smaller, but this is a definition I saw online, which I think is complete in a way, but it's a little bit different from what I'm suggesting here. So let's go through my definition and make sure that we're all in agreement here in terms of our scope. So what we're talking about with high mix, low volume is a production manufacturing environment with many different models or products. So you could have base models, but typically in a high mix, low volume environment, you've got lots of options, right? Or you have configured products. For example, you could have a base model 100, but the customer could order literally hundreds or thousands of changes to that base model or additions or options. So this is very typical, and I'm including that in the high mix, low volume. So it doesn't have to be completely different products. It could be base models, but with lots of choices. To the point where almost every product coming down the production line could have some differences. That is not unknown. So the main point is, from a material point of view, we have lots of different material that we have to manage. By manage, I mean we have to buy it, right? Get it in-house, and then we have to get it to the point of use at the right time, in the right quantity, in the right container, right, et cetera, all of those challenges. So that's the essence of high mix, low volume. The order quantities in a high mix, low volume environment could be as low as a single unit. That means every unit coming down the line is different in some way. Or we could be talking about building in small batches. So we're building the same unit, but in very small quantities, as would be typical, say, in an aerospace environment. Not every model is different, not every product is different coming down the line, but we're building in small batches, and we're not building that many of the same item. Now, how do we build these? Well, we may be building them on a line, on the same production line, or we may have a cellular kind of configuration. There's not much, in my mind, there's not much difference between a cell and a line other than the number of resources. In my mind, a cell is a smaller number of stations, typically self-contained and oftentimes just focused on assembly, but it could be a machining cell, but it's a smaller self-contained area, whereas a line is more workstations, more people involved. But other than that, the characteristics are very simple. So let me give you a couple examples here that we've worked with that are very much in this mold of high mix, low volume. First one is building controls. By that, I mean thermostats. It's a company in Chicago that we worked with. They're making thermostats and various control systems for skyscrapers, office buildings, those kind of things. And this company had been around for a while, and a classic example of never getting rid of a product, because they might have an old thermostat that was installed literally 50 years ago, and as a matter of company policy, they're still supporting it. So what we saw here in this environment was a lot of cells, big production area, but the volume of any individual product was extremely low. And as a consequence, they had a lot of cells that were idle most of the week. They'd only run some of these cells a few hours a week to produce those few quantities. Now, why didn't they mix? You might ask yourself, why didn't they mix these and reduce the number of cells they had? Well, the biggest constraint they had was tooling and test equipment. So they had unique tooling and test equipment that they figured it was easier to set up a cell with the right tooling and test equipment and just leave it set up rather than trying to swap out all this equipment when they did a model changeover in a cell. So that was the logic there. So what you saw was a very quiet, huge area without that many people. So very much in the high mix, low volume environment. Here's another one, jet engine insulation covers. So this is aerospace. This is a company in California, and they were making insulation covers all the way from the size of your fist maybe, or even smaller, that might cover just a bolt head, to large insulation covers that would go on the space shuttle or go on large jet engines. So huge variety, several thousand, if you can believe that, different insulation covers. But of course, being aerospace, you're not building that many of any of these individual products. I mean, how many big jet engines are being built? It may seem like a lot, but compared to automotive or electronics or other industries, it's tiny volume. So they would have an order quantity of 10, 20, maybe 50 at the most, and have to build those. And then when are they going to build them again? Who knows? Right? Until they don't know either until they get an order. So that's a second example of the kind of environment we're talking about. Third one is fork trucks. If you've been to any of our previous webinars, you'll know that we mentioned we have spent a lot of time at Toyota Material Handling in Columbus, Indiana. So this is more of an automotive environment, not quite the volume of automotive. Volume in this case currently is around 130 fork trucks a day, but lots of options. So any individual fork truck, the order quantity could be as low as one, or a small quantity, probably has some unique kind of characteristic to it. And they do have base models, but they have over 50 of them. So starting point is 50 different models. And then on top of that, any of those 50 different models could have some unique options that the customer requested. Different paint, for example, or different kinds of mirror systems or electronics, or you name it. So again, they're having to deal with that, where almost every unit coming down the line has something unique about it, and manage that properly. So that's another example of high mix, low volume. Low volume from the point of view of every model could be different. So the volume would be one from that point of view. Okay, so I hope that that sets the boundaries then in terms of what we're talking about. Let's continue with some discussion of that. Industries where typically the production environment is high mix, low volume. Aerospace. Again, as I mentioned, we don't build that many airplanes relative to other types of products, so it's inherently low volume. And these aerospace suppliers in particular typically have a range of products that they're supplying, but not that many of any individual product. The other one is electronics and computers. Now, some electronics and computers are very high volume, and very low mix. So mass production of some of these items. But we do have other types of electronics and computer products that are highly customized. For example, data storage, where a customer has very specific requirements, high involvement with your engineering design department, but you're not really building that many of any individual system, but they're configured to order or highly customized. So that would not be unusual. Industrial products, what am I talking about here? I can think of a few places we've worked. One was industrial pumps, where again, they're building what may seem like a lot, but a lot of variety, a lot of unique characteristics, and mixing different pump sizes going down the line and having to deliver a lot of material, right, to the same line. And then in general, I've listed here mixed model production. Again, to remind those of you that have worked with us in the past or been to previous webinars, we, Leonardo Group, we're kind of the mixed model guys. So our area of specialty and focus is mixed model line design and mixed model material management. So mixed model, meaning building different models on the same line, is inherently high mix, low volume. Low volume from the point of view of every product could be different in some way. So having to deal with a lot of different materials is the main point. Now let me just say a quick word about job shops versus flow manufacturing. I don't really think that job shops fit very well within the scope, because when I think of job shops, I think of not only a lot of different products and a lot of different material, but a lot of different routings. So in a job, what differentiates a job shop from a flow manufacturing or mixed model flow manufacturing environment, in my mind, is a job shop doesn't have a line. It doesn't have the same sequential build process that we'd expect to see in flow manufacturing. So no doubt there are opportunities to take what we'll be talking about here in this webinar and apply it to pure job shops, where the routings, if you laid them all on top of each other, would look like a bowl of spaghetti. But I'm not really including that directly into this discussion. I'm thinking more of production lines or cells, where you have sequential work and you're trying to deliver the material to a running line. Okay, so one more point in background, and then we'll get into the heart of this, the guts of it. What are our goals when we talk about material delivery? And by the way, delivery means how do we get the material that we have that was delivered from outside, how do we get it to where it's consumed, which is what I'm calling the point of use or points of use. So how do we get it there and meet these following criteria? Number one, don't run out. So probably that's the most important thing. When you stop the line because you ran out of material, that's a big negative, because not only are you impacting all your internal processes, right? All the internal customers and the operators there with nothing to do, et cetera. Huge waste, huge cost, but you're also impacting potentially your outside customers who are waiting for those products. So don't run out is kind of a big deal. We don't want to do that. So we want to have a system that's pretty bulletproof. Now, I'm not including in don't run out, I'm not including in this discussion your ability to procure the material from outside, from the outside supplier or from an internal department. That's outside the scope of this delivery. We're just saying, how do you design a delivery system to get it to where it needs to be in the right time, in the right place, in the right quantity? The issue with getting it from outside suppliers is more of a supply chain issue, hugely important, but different. Okay, second point here is don't have too much. So don't run out. One way to accomplish that is to have a lot of material, right, at the point of use. We don't want that either. So we want a strategy that allows us to not only not run out, have a pretty bulletproof process for that, but also manage the quantities that we have in process, you know, and staged at the points of use. So we need to keep that in mind. Don't have too much. And the third point is you could accomplish those first two, but at a huge cost. So we need to have a process, a material delivery process that's efficient, right? That we can move this material in an efficient kind of way. So don't waste money means don't have more material handlers than you need to accomplish this task. And primarily when we say don't waste money, we mean from a total company perspective. So we might be willing to invest more, as we'll talk about here in a minute, on material handling if that will have an offsetting savings that's greater than that cost in terms of things like operator productivity and saving floor space and so on. Now, with material delivery systems or material flow in general, we have what are called the 7 rights that we use. I first heard about this concept of rights in use with hospital examples. For example, I don't know if it was 7 or 6 or 5, but there were the rights of medication delivery, right, to patients. So you want to have the right medication in the right quantity delivered at the right time and so on. And they developed these rights as a way to establish some guidelines for designing a medication, right, prescription drug delivery system in a hospital. So we've adopted that rights concept to materials or material flow. So here are the 7 rights. We have the right part, the right quantity, the right location, the right container, the right sequence, the right order, the right time, and the right total cost. So total cost is from the company, not just from the material management, material handling department, but from a company perspective, the right total cost. So if we keep all these rights in mind when we design our system, we'll be doing well. Okay, so let's get into it. Let's get into the guts of the matter here. Here's the classic lean material delivery chain. So on the far left, we have outside suppliers. So at some point, everything starts with an outside supplier, right? Unless you make your product out of air that's free. At some point, if you go far enough upstream, you've got an outside supplier providing something. And so in this block diagram, and by the way, I'm going to keep all of our examples at this level block diagram. So not super sophisticated, but I think communicates the point. So we have a supplier. Now that supplier can deliver what we need either to what we're calling a warehouse. So a warehouse would be a controlled area, oftentimes off-site, doesn't have to be, could be on-site, but it's a controlled area where everything going in is transacted, everything's going out is transacted. You can cycle count inside the warehouse. And most of your material in most companies is in what we're calling the warehouse. Now, if you're a little more mature in your lean journey, you can reduce the amount of material in the warehouse and actually have the supplier directly delivered to what we're calling a supermarket, or sometimes people call this a market. I like the idea of supermarket better than market because market is a very general term, could mean a lot of different things. But in a supermarket, you have more a specific description of what we're talking about here. A small quantity of goods, and we replenish them as they are consumed. So a supermarket is typically under Kanban control. But in this example, we have a supplier delivering directly to the supermarket, bypassing the warehouse. So that's an option. We say that's an option because you don't want to do that if you don't have confidence in the supplier, confidence in their quality, in their ability to deliver in small quantities at a reasonable cost, et cetera. So typically this takes some time to evolve into. So for many of you listening, the warehouse is the intermediate step. And then from warehouse, we pull to the supermarket. And then from the supermarket, we deliver material to what I call the points of use. So these are the workstations where the material is actually consumed. Now, I have the arrows pointing, to the right. You might say, but gee, what happened to the concept of pull systems? Well, the material is going from left to right, but the signals ideally are going from right to left. So we have a Kanban or a signal of some kind at the points of use, going back to the supermarket and then going back to the warehouse or back to the supplier directly. So this is the classic lean material delivery chain, just to set the baseline of how we normally set things up. But now we're talking about high mix, low volume. So let's get into it. I'm offering 5 options. These are different strategies that we've seen, right, that we've implemented depending on the environment. So let's go through them one by one. We'll discuss what they are and then show you the block diagram of how that might work for each of these. At the very end of the webinar, we're going to talk about how you might decide which one to choose. And of course, you don't have to choose one. We have one of the options, which is hybrid, so a mix of different systems. So let's look at this first one, zero kitting. So in the past, in my background as a lean consultant, I'm saying maybe 10 years ago or maybe even less, our philosophy with material is try to avoid kitting at all costs. Because the logic at the time was that kitting is extra effort and material handling is is an overhead function or non-value added kind of activity. So if we can figure out ways to just deliver that material to where it's consumed without having to kit it, that would be preferable. Now, I'm noticing a sea change in that attitude over the last few years, where companies, especially say leading lean companies, are much more open to this concept of kitting for a number of reasons. One of the reasons is floor space, on the factory floor. Another reason is quality. Reducing the choices that an operator has to make. And the third reason is operator productivity. Giving an operator exactly what they need so they don't have to do part selection, they don't have to look for parts. So I see a change here. But in any case, we're looking at option one, zero kitting. So if we have the philosophy that kitting is bad and we want to try to eliminate it, then one option is to try to set up our material delivery system so we don't have to do it. So what is zero kitting? It's organizing all the material that's needed at or near the points of use. So when we're talking about, as we are with high mix, low volume, a lot of material, that becomes a challenge. But if you can do it, then zero kitting might be an option. Now, if you don't have space at the point of use, I'm saying in front of the operator or at the workstation, then could you have a strategy using exchange carts? In other words, all the material is at or nearby, but when you have a particular model, the operator might have to take a few steps, pull in a cart with the specific material for that model or those models, and push another cart back. That's an option. Right. Now, when would you use zero kitting? Well, when SMEM, you probably have never seen that before because I just made up that acronym. You've heard of SMED, right? Single minute exchange of dies. So I just made up this acronym. I don't know if it's going to stick. I don't think it will. But SMEM, single minute exchange of materials. So if you can switch over, in other words, you have more material than will fit in front of the operator. If you can switch over or change over that material in an efficient way and fairly quickly, then you might be able to achieve this zero kitting strategy. Right? And again, the technique there that we've seen is quick docking and undocking material carts that are stored, say, across the aisle or behind, and there is a very fast changeover that would be required, but hopefully very, very fast, where you could push away one cart, pull in another cart, et cetera. So why would you want to do this? So when I say positive, negative, what are the benefits, or what are the positive aspects of zero kitting? Well, you're avoiding any special handling, right? By having the material for any model available to the operator via a normal Kanban kind of replenishment. So you eliminate the need to have a kitting cell or kitting activity, and the signal to replenish those carts can be via Kanban, right? The way you might do in a classic material replenishment environment. Now, the negative, you've got more operator involvement. Number one, they're going to have to pick the right parts. And I mentioned a minute or so ago that can introduce errors, right? Especially if parts look very similar. So you're asking them to do more part selection. Second negative, you're consuming quite a bit more floor space. Because remember, you're trying to stock every item that they might need at the station itself. So clearly, point of use inventory is going to go up. In fact, this is probably the maximum strategy for point of use inventory. And I'm saying not for high mix, because when you start getting the realm of very high mix, the number of different items you would have to control using this method would be untenable, right? You'd have too many. You just run out of space as a viable strategy. But if you have fewer options and you can make this work, then this is certainly a perfectly viable choice. So here's the block diagram. Again, a lot of this is classic kind of style. So we have supplier to warehouse or supplier to supermarket. But then from the supermarket's responding to signals from these point of use carts. Could be a two-bin system, say, on these carts. So at any given point of use, you might have more than one cart, you probably do. But in terms of replenishing those carts, it would be kind of a standard methodology. As a bin is empty, then it gets put in a collection spot, and then that signal goes back to a supermarket and it gets replenished, put back on the cart. you would usually, to get this to work, you would usually have to have a longer takt time. If you have a very short takt time, it's hard to see how this would work because you do have a changeover when you're swapping out the carts. You do have a changeover involved. So it would be hard to overcome that changeover time if you have a very short takt time kind of environment. And you could actually use this as well for running small batches. So small order quantities could use this methodology. So I have seen this, this method work, but usually it's in an environment where the number of different part numbers that had to be managed is lower, right? Not that many. Still high mix, low volume, still fits within that parameter, but not on the extreme in terms of the number of items that would need to be stored on these cards. Right? So that's your first choice. Option number 2, kitting cells. So now we're entering the realm of kitting. So kitting is selecting a set of parts, right? Not in front of the operator, but delivering to the operator a set of parts to be used for a specific model and based on a production sequence. So you'd have to have a lineup or production plan. You'd actually have to have an MRP system, material requirements planning system, that would tell you not only what's required for that unit, but where, and eliminate from the pick list that it's going to produce, or from the kitting list, the items that are already there, if you have a hybrid kind of scenario. Now, this could be a set or a kit for a small batch, or it could be for even as low as a single model. Now, where, in this scenario, where is the kitting done? Well, it's done at the supermarket itself. Not adjacent, although the supermarket is somewhere in the area, it's not adjacent to the points of use. And the reason for that is we're assuming in this scenario that you have a supermarket that's supplying many different points of use, right? So we have multiple customers that you're supplying to. Now, when would you want to use this one, kitting cells? Well, clearly it would be a scenario where the zero kitting is not going to work for you. You have too much variety to present at the point of use, and you have a shared supermarket, right, feeding lots of different locations. And so what you do is you'd set up a cell, meaning a number of kitting stations, and organize that material in the supermarket logically, right, so that ideally someone could just walk, in a U shape or walk down the line and restock kitting bins or kitting trays in an efficient way. Now, why would you want this? Well, big positive is huge space saver at the point of use. So this is why I've seen some companies in recent years go to this kind of strategy or something very similar, because they didn't want to build a new factory. They were running out of space. They were growing, but they were running out of space on the production lines. And so to shrink those lines down, to add enough capacity on the assembly lines or on the production lines, they needed to reduce the amount of material, raw material that was stored there. And so this was a way to do that. Also, there are the additional benefits I mentioned earlier. If we're providing the operators with just what they need, then you're reducing the part selection errors. And probably operator productivity is going to go up, right? It's going to improve. One other benefit that I should mention here is if you're providing exactly the kits that they need, then the amount of space between workstations can be cut down significantly. So again, back to the space saver, the size of those workbenches that maybe you have currently can be changed. Adding or more workstations can be added if you need additional capacity. So nice benefit there. On the negative side, now you're adding a whole new process called kitting. And this is the original objection, right, that people have had for years. Gee, I've got to add more people. I'm hiring more material handlers to do this kind of effort. And I'm going to need to manage a whole new process. I'm going to have to manage the sequence. People are going to need to keep track and know what to do next in terms of preparing these kits. Now, personally, not that concerned about adding additional material handling, as long as the benefit that we see onto the positive side, benefit in terms of operator productivity and floor space and so on, more than offsets that So we need to keep that in mind. If we have a silo mentality, we're just looking at our department, we're the material department, then it may look like we're increasing the resources on that side, which you are. But again, if you're reducing the need to add additional operators on the operator side, then that's very positive. So you'd have to do that analysis. All right, so that's a kitting cell, again, on the factory floor. Oh, there's one other benefit here. If you have a kitting cell next to the supermarket, what if there's a problem with a part in that kit? What if I drop a part and it rolls under a machine, right? I need a new one. It's not in the kit. I'm short a part. That could happen, right? That's easy to imagine. If the supermarket is the supplier of that kit, then it's fairly efficient to get another one on an exception basis, right? So this is, you're pulling the signal, you're pulling the cord for this, but it should be fairly easy to get that replacement part if the supermarket is somewhere physically adjacent. Okay, so that's another big benefit of having a supermarket on the floor. Okay, so far let's take a quick pause here and answer a question that I see here. It was, how do you convince material personnel to kit? Well, again, I think the answer to that is it needs to make sense from a cost perspective. It's not a matter of convincing material personnel in isolation. It's a matter of looking at the total benefits versus the cost. So this would have to be a higher level analysis of what are the costs of adding a kitting function, and then what are the potential savings. I'll jump ahead a little bit to answer this question by sharing with you a story of a tour I took recently. I mean, last year, I was at Georgetown Toyota, which is where they make the Camrys, Avalons, right? A couple other vehicles there. So pretty high volume automotive. And I saw almost no classic, as I was expecting to see, I saw almost no classic material delivery systems. What I saw was a lot of kitting of a different type that we're going to get to in a minute. But I asked them, what's the deal here? How did you, I mean, it looks like a transformation has happened here, because almost every line, every feeder line, engines, dashboards, you name it, they were all running on kits. And it was pretty high volume too. And I said, how did you, or why did you make this change? And he said, well, there were three benefits. Number one, and I've mentioned these earlier, but I'll just repeat them. There were three benefits that really drove us to this. Number one was we were running out of space. And we didn't want to build another building. Number two, we had quality concerns, because occasionally there were, parts were misselected, right? Operator error. And we'd catch them, but still this was happening. And then the third one was when we went to this, we got about a 5% productivity gain at the assembly lines. So 5% may not sound like earth shattering, but this is in an environment that was already pretty darn efficient. So an additional 5%. So if you have all the data with you, then I think it's a more reasonable discussion that you can have by sitting everyone around the table and getting everyone to work as a team. But if you don't have that data, then what you need to do is a pilot, right? Try it out. In fact, that's generally recommended. If you have a suggestion that you want to try, but you're not sure what the results are going to be, don't bet the farm on it. Just pick an area, right? Pick a process or pick a feeder line, and make sure you document the current state in detail, and then you make the change, and then you look at the results. So that's the typical plan, do, check, act methodology. And if it looks positive, then it's pretty hard to argue, again, for material personnel argue against it if you have the data. If you don't have the data, then you're kind of speculating. Okay, so let's go on to the next one. Here's the example of the kitting cell. So what we have here is, again, classic up to the supermarket, and then the supermarket, before we go to the points of use, we have a kitting process. And I added the reminder here, sequence. So materials stored in the supermarket, and then from there we prepare kits in the form of trays or bins of the parts that are going to be required, and those are delivered to the points of use. You may even have a kit that travels with the unit. So it's not a matter of delivering a kit to lots of different stations. It might just be delivered to the first station. And then that material isn't consumed in its entirety at the first station, but it travels with the unit down the line with all the parts they need for that unit. That'd be a good way of having a single point of delivery right at the line and not having to deliver material in a lot of different places. But this is how it would look. So this kitting process and the supermarket are really co-located, right? They're together. And then the points of use are wherever they are. Not that far away, but they're not exactly next to the supermarket necessarily. All right, so option 3, how are we doing on time? So it's 11:40 Mountain Time, so we got 20 minutes. I think we can make it. So next one's called kitting integration. This is a great one. This is really, I've seen some great results with this one. So what we're talking about here is, yes, we have too much variety. We need to do some kitting, selecting of parts. We can't just stage them in front of the different workstations. That's understood. But what we're going to do here is, instead of having a supermarket and a kitting process that's somewhat detached, we're going to connect it directly. So we're going to essentially add a material replenishment loop into our production line, and it's going to run at the same takt time as the line. So when would we use this? Well, if you have enough volume to justify setting up, which is essentially be a specialty supermarket, right, with the parts for this line only, and it can handle very high mix, potentially. And what we're going to do here is integrate as an option the workstations and the material storage into the same unit. And I'll show you an example of that here in a minute. So what we're talking about here is, we don't have a material selection or a kitting process that's separate from the line. It's built into the line itself. So the cart or the container for the material or the workstation itself would go through a parts selection process for that specific unit. Everyone could be different. And then you have some workstations that it would pass through. And at the end of the line, when that unit is done, that cart or that container would go back to the beginning of the line and get restocked for the next unit in the sequence. Now, why would we want to do this, or what are the benefits? Positive minimum WIP inventory, because you're selecting the parts exactly unit by unit. So you don't have a lot of extra material there. You're replenishing the line supermarket via Kanban. Yes, the supermarket part of this design is replenished from the warehouse or from supplier via Kanban, as in the classic model, but the material going to each unit is selected for that unit. So this is true single piece flow of materials. Companies like Toyota have single piece flow as kind of a philosophical goal. And it's easy to understand when we're talking about units, but less easy to grasp when we talk about extending that vision, right, that goal, to materials. But they think about this, and this would be a way of actually achieving that. Now, negative is, you've got really an additional set of stations and processes that need to be designed and balanced to run with the line takt time. Also, you're occupying prime space, which is right on the factory floor, right as part of your production line. And then you have this issue of, how do you move this material, right, through these part selection stages, right, part selection stations, and then into the actual workstations. So you'd have to come up with a way of doing that. So let's look at an example here, and then I'll actually show you a picture of how this might work. So again, supplier to warehouse, and I put a dotted line around supermarket and the kitting process and the single line or the cell. They're all within this dotted line, meaning it's all an integrated process. So the supermarket is actually kind of a series of stations within this work area. And then the container, which could be, again, a cart or a bin or an actual movable workstation, is going to go through this supermarket as a series of picking stations. and then it's going to go back to this single line or to a cell, and then once that unit is completed, it's going to go back through the loop again. So you have a continuously flowing loop all running at the same takt time. So pretty cool. Now let me show you an example of something like that. This picture is blurry to me even. Sorry, I couldn't get a better one. But here's an example of what we're talking about here. A little bit different than what I just described, but it's a workstation that has the parts needed for that unit. Every unit could be different. It's a workstation that's on wheels. It's a cart, and it has bins for various parts. Now, the difference here in this example, and again, I hope you can see this, is there's some bins down below that are essentially Kanban bins. So these are not the parts for a single unit. It's a small quantity of fasteners for the most part, hardware type items. And we have some of those bins for the commonly used items up on top as well. But for the most part, the unique items are sitting on top of this cart in a fixture or in a specific designated location. And then the cart, which is on wheels, is actually an AGV, is going to move to the various workstations where the work is done. The tooling, the fixturing, the tools are all there. And that unit is going to go down a series of assembly stations and be put together. And then the AGV on its own, right, without a human being pushing it, is going to loop around. See the black line in the picture on the floor? It's going to follow that path and go back to the picking cells and get restocked for the next unit in the sequence. So it's just a continuous loop running at the takt time that this line was designed for, and just loop through, and every unit could be different. So works pretty well. And they're handling, we calculated, this is a project, we calculated the number of combinations that could be built on these stations, and it was in, I'm not exaggerating, it was in the hundreds of thousands because of all the different base models plus options that could be specified by the customer. So it was huge variety of different things could be built on these same kind of universal workstations. So this was very cool, I would say. And I've seen similar things like this at Toyota Georgetown that I mentioned earlier, where they're building the Camrys. Similar kinds of things. AGVs are actually doing the physical movement, but they're going through a little loop where these carts get restocked, and then the carts go to the people actually doing the work, and then they loop back around and get restocked again for the next one in the sequence. This happens to be a little more sophisticated example of that. Great. Now, before we go on, let me announce something here real quick, since I've got your attention, hopefully. We have another webinar coming up in just 2 days, which is another really, it's going to be, I think, a really interesting one. In the year 2002, there was an article that was published in the Wall Street Journal, the Harvard Business Review, called Read a Plant Fast. And it's become a well-known methodology. Some of you may be familiar with this. It's a really interesting story. I'll just share with you briefly. It was a plant manager with a well-known company, automotive, and he had about a 1-hour plant visit by these folks from Japan. They were competitors, but they said, look, we'll just walk through your plant. We won't take any notes. We just take a look, and then you can do the same for our factory in Japan. You can come over there, send whoever you want, but same rules, right? Just take a walk through. You can't take notes or you can't take pictures. And so he agreed, and they did. And then he sent a bunch of his folks or best folks over there to take a look at what they were doing in Japan. And a few weeks later, he got a report from this competitor, basically outlining what they saw in their conclusions, and they nailed it. They nailed it down to, profitability and amount of work in process inventory and, all these very specific things. They just nailed it. And meanwhile, his folks that went over there learned basically nothing, right? Didn't come up with anything very concrete. So that got the wheels turning in terms of how did they do this? And he developed this methodology called Read a Plant Fast. By fast, we mean like an hour or two, right? Be able to nail a lean environment in the terms of what to look for. So what I've done here in this webinar is I've just pulled out of this Read a Plant Fast methodology the material-related issues. And so we're going to go through what those are. So what would you, if you had half an hour to walk through your competitor's factory or your own for that, what would you look for? And then how do you rate that? And how do you get a level of maturity in terms of lean material management? So that's the goal here. It's going to be a really great one. We'll be sending you a follow-up email after this webinar, and there'll be a link in there you can register for this if you haven't already. I think we've been sending out some announcements, but we'll send you specifically one. That'll be on Thursday, same time, same place. So 11 o'clock Mountain Time, 2 days from now. All right, so let's move on. Remote kitting. So this is similar to the kitting that we saw earlier, but in this case, it's remote, meaning the kits are prepared off-site. So they're not next to the supermarket. We're pulling material from the warehouse area, usually. So you have a kitting cell in the warehouse, and you're delivering them to another location, to the points of use as needed. So we're bypassing the supermarket. So when do you use something like this? Well, you could have a scenario where the material mix is so high that even setting up a supermarket would be a challenge. There are too many items to really want to set up a supermarket. There are definite benefits to a supermarket. There are the three main benefits: early warning, improving inventory turnover, early warning signal for shortages, ease of replenishment is a big one. But you could have scenarios where it really becomes difficult because of the variety that you have. Another case where you might need to have remote kitting is if you have special kitting equipment. I can think of one example where they were preparing kits of cut specialty materials that needed a special environment. They had a large cutting bed, you know, with the robotic blades that would cut these templates out of this material, but they needed a special environment. They needed some air control on that. There was a certain hazard to that. And so setting that up right on the factory floor was not really a good idea or even possible. So positive, we save some factory floor space for sure, because we're not doing it on the factory floor. You could have improved safety or environmental concerns if you have those. There are some negatives though. If you're in a different place while you're preparing these kits, then you've got slow response to something unplanned. I need a part, I need it now. It's not there, it's not in the supermarket. There is no supermarket. And so you're gonna have longer downtimes if you have something like that. You're not able to respond as flexibly. And you've got more material handling because it's not co-located to your points of use. It's not nearby. It's somewhere, you know, could be some distance away. So you have a longer move that you have to deal with. Also, if you're talking about pulling material from a warehouse, you're going to have a potentially less, depending on what you do, a less efficient material retrieval process in the warehouse, right? Because things are not organized the way you'd like to have them. Now you could do that, but they're typically not organized the way you'd like to have them for picking, right? So more walking around, essentially getting the stuff, unless you do some corrective action on that one. Also, if the kit process is not within visual contact of the customer, there might be a temptation, unless you do something to overcome it, to push kits, meaning not be that concerned about whether the kit's needed or not, but simply kit based on a schedule, and here's the kit, and my job is done. And we don't want that. And I'll show you how we would overcome that here in a minute. And also, it's typically not connected to the line tack time. You don't have this rhythm or beat that you'd like to have. Now that line tack time, the connection to the line tack time doesn't have to be one-to-one. It could be a kitting cell that's running to a multiple of the line tack time. For example, every 8 units we provide a kit, that kind of thing. But you want to have some connection with the kitting process to the rhythm or beat of the production line, even if it's a multiple of that. So here's what it would look like in a picture. You've got a supplier, and then you have the material coming into the warehouse. You've got a lot of this material, remember, a lot of variety, and you have a kitting process that you set up here in the factory, in the warehouse area. Now you could have a kind of a mini supermarket, but again, you've got a lot of material, so that was the challenge to begin with. But maybe you have a little more physical space in the warehouse to do that. But you've got a kitting process, and then it gets delivered, maybe even to another building, right? Another building to the points of use. So that is how this works, and you'll notice there's no supermarket in this case. All right, so that's an example. And I mentioned a company here. This is an actual company, High Temp Insulation. This is exactly what they were doing. This is the company that was making the insulation covers for jet engines, and the kitting process involved cutting this material. You can imagine asbestos was involved And so this was not something they could do on the factory floor. They had to use controlled environment, and they had these cutting beds, producing kits of maybe 10 pieces, 20 pieces, small batches, but it really had to be done in a controlled area, and it was not done. It was in the same building, but an entirely different area, not that close, and in a controlled environment. So remote kitting. Now here is the last one we'll get to, which is probably the most common, which is called hybrid material delivery. So we're saying here, you don't have to pick one of these four. You can do a combination thereof, try different techniques for different things. So it's a combination of the methods we just covered. So what we're saying here is some percentage of the items that you need to manage are going to be stocked at the workstations, at the points of use, via Kanban usually. And then other parts will have to be kitted, or they'll have to be sequenced. And so this is an extremely common way of handling a high mix, low volume environment. Now, you would use this when you have I said high, but a certain percentage of the parts that are consumed are common. So it's not going to work super well when you have every unit with totally different bill of material. But when a high percentage of the parts are common, used on multiple base models, for example, then you'd want to set those parts up under a classic Kanban methodology, either two-bin or multi-bin Kanban. You can even use this methodology for the same type of item. For example, hydraulic cylinders. We've seen an example where this particular factory had, I think it was something like 12 different hydraulic cylinders, but only 2 or 3 of them were the high runners, and the others were much lower volume. So instead of setting up 12 Kanban multi-bin scenarios, they set up 3 for the high runners under classic Kanban replenishment, right, from a supermarket back to the line. And then the other low volume hydraulic cylinders were sequenced or kitted, right, delivered to the line in these specially designed carts in the right order, so that if the operator needed a standard hydraulic cylinder, one of the 3, he or she would just go pick that right out of the Kanban rack. But if they needed one of these specialty cylinders, it would be in these sequence carts, waiting, right, to be consumed. And then, of course, the carts, they had more than one, they'd be swapped out and restocked back in the supermarket. So why would we want to do this? Well, this is going to reduce the number of items that require special handling, obviously. So you don't have to kit everything, in other words. You've got kits, yes, but it's the kits with the unique items only that you'd need to apply any special effort to or special handling. Now, what is the negative of this? Well, you do have more space you're consuming at the points of use. You'd have more inventory that you're stocking at the points of use. You have more management of this hybrid environment. So you need to keep track of which units are coming down. You need to have a partial kit process so that the people that are doing this part selection or sequencing know what to pick. But other than that, this is pretty classic, right? This is pretty classic. I noticed some people are leaving. Hang in there for just a minute or two. I'm going to give you a couple examples. I know it's 11:58. We might run over a few minutes, but not much. So here's the hybrid scenario. You've got a classic supplier to warehouse to supermarket or supplier to supermarket, and then some of the items are going to go through a kitting or sequencing process, and some of the items are going to be replenished from the supermarket via a Kanban signal. Again, classic, extremely common way to handle this. And this is, in fact, how they're doing it at Toyota Material Handling in Columbus, Indiana. Some of the items, many of them are under standard Kanban control, and many of the items are either high dollar items coming from Japan that are not good candidates for Kanban, or simply the unique options that are typically found on every single unit coming down the line. So they're managing both. I think it's actually 3 different areas. So they're regular delivery tuggers that come by often. Their cycle on their tuggers is about 32 minutes, if I recall correctly. But those tuggers are going to get restocked at 3 different areas: imported parts, Kanban area, and then sequenced parts. And just do that loop, continually many times a day. Okay, couple tricks. If you have a remote kitting process, What you don't want to have them do is push kits. So what you don't want is a kitting department with a dispatch list and some kind of rule that says X number of days before it seems to be due in production, we're going to prepare this kit and we're going to push it to the production area. You don't want that. Now they need to know what to do next, but they use the dispatch report as a sequencing, not as a demand signal directly. So the demand signal is going to come from, in this example, a rack. I mean, this is something we actually did. So we had a kit rack. So this is going to hold a tub of parts in the example we worked on. It's going to hold a certain number of those. And the signal would be an empty space on that shelf or a card that represents an empty space on that shelf. So the kitting department is responding to those signals. Give me another one. What was happening prior to this methodology is they were flooding the factory floor with kits that were not needed. And if kits sit around for a while, you know what happens. Parts get cannibalized, they get lost, they get dirty, all those things. So we set in place a pull signal, but it wasn't for a part or a specific item, it was for a kit. And that was very visual. So if you have an empty spot on one of these shelves, bring me another one, basically. And the spaces were organized in, first out kind of logic. So that's a great way of controlling the kits coming out on the factory floor with enough lead time from when the kitting department gets the signal to be able to do the work that they need to do. Also needs to be considered. Here's another great one. This is actually from Toyota Material Handling. We got permission to use this. It's a rhythm wheel for a sequencing department. So these are all the unique parts for a fork truck. They could be different. So we have a supermarket set up here, but this person is selecting a number of different parts. You can see them kind of listed here: covers, steps, toe boards, pump motors. So these items are being selected here, but the idea is that they're running on a rhythm or beat that's tied to the takt time of the line. And this gives them some guidance in terms of the picking sequence and the amount of time expectation to fulfill these requirements within that multiple of the takt time of the line. So it's really tied to the frequency of the tuggers coming by, which is, again, about every 32 minutes or so, this sequence of work would be done. And it was this rhythm wheel was just a little reminder of that sequence and kind of how it would break out in terms of the time requirements. So this was pretty cool, and it's working extremely well. So last point, how to decide. There are some parameters that you would need to establish for your particular factory that you need to understand to get some feel for what the right methodology might be for your factory. So some of the things you need to know are, what's your current level of part commonality, model to model? So do you have common parts that are used on base models, for example, or is every product very unique? Do you have material traceability requirements? For example, aerospace has pretty strict traceability. So if there's an air accident, you can trace back, if you need to, all the way to, in some cases, the mine where the titanium was mined. Also, medical products have traceability requirements. Military products have traceability requirements, et cetera. So if you have that, it makes it more complicated, right, to use just a standard classic methodology. Number of different models. So what are we talking about here in terms of variety? Number of different active part numbers. So how many are we trying to manage? Warehouse distance from the point of use. That's good to know. Is it in the same building? Is it down the across the parking lot, or is it, in some cases, we've seen quite a few miles away? That could make a difference in what you choose. And then finally, what's your current level of mixed model manufacturing? Are you doing true mixed modeling? What's your current manufacturing methodology? That's going to make a difference as well. Now, to help you in that, we're going to send this to you. We don't really have time to get into how this is going to work, but I think you'll see. What this is a simple spreadsheet that lets you set on a scale of 1 to 100 your current level of maturity or your current level of reality in these different parameters. And then there's if you click on this, you'll see the rule. It's a bunch of if statements. Will give you a suggested strategy if you have these characteristics. So for example, level of part commonality, 1 would be all the models have exactly the same bill of materials, so there's complete commonality, or A 100 would be all models have completely different parts. So if you're at a 100, you're really looking at a remote kitting methodology, because probably you're going to have way too much different material to talk about setting up a supermarket or stocking the material at the workstations. So that's the kind of logic we've applied here. So this isn't rocket science, but it's very useful in terms of structuring your thinking, structuring your discussion, with your team, using something like this, as opposed to just having an open-ended discussion with no tool, no methodology. So we'll send this to you. It's an Excel file. And so you'll all get this, and you can modify it to your heart's delight. Okay, that's it. So in terms of what's coming up here, hang in with this for just another 60 seconds. This is a great opportunity. We have an actual workshop on this topic and lots of other topics, plus see it in action at Toyota. We do these quarterly at Toyota Material Handling in Columbus. Our next one's on June 7th through the 9th, focused entirely on material management. This is one of the best run factories in maybe the world, certainly North America, and you can see a lot of the techniques and methods that we talk about, you can see them in action at this plant. Now, the special offer for you guys, you're still within a time frame. Time is running out, but this is in a little more than a month, right? June 7th. If you can get your registration in within 7 days, we're saying here, take another $200 off that early bird discount. So $500 off the class. This is just for you guys. No one else knows about this. And the discount code in the registration system is webinar 0503. We'll include a link in the follow-up email so you can get to this page to find out what's included in this workshop. What are we talking about? It's 3 full days at the factory, right, at Toyota Material Handling in Ohio. Right, so with that, we're done. So if you found this webinar valuable, let us know. Also, we took you seriously on your suggestions. This is one of them, right? So if you have any other topics you'd like us to think about and maybe do a webinar on, we'd be delighted to hear you and do it. Okay, so with that, I'll let you go. One other thing. If you missed part of this, I think we just got a message. If you missed part of it, you will get a link and there will be a replay. So you'll be able to watch this over again. Okay. One other question, Ashok, what does SMEM mean? That's an acronym I made up, single minute exchange of material. I don't think that's going to catch on, as I said, but that's what it meant. All right, with that, we'll let you go. Thanks for attending. We ran a few minutes over, but appreciate your sticking with us. Bye now. See you next time. See you on Thursday if you can make it.